All right, we are going to start objective 33 today. We are going to model data using lines and curves of regressions, and we're going to make predictions using the line of best fit equations. Any questions about that? All right, just reminding you while you're still getting this down, I won't be here tomorrow. Ms. Radford will be with you. You're going to be working on an SOL prep. I call it a little packet, but it's um, anyway, so you'll be working on that. When is that packet due? Monday. I do not plan on you having a lot of homework over the weekend. It's a holiday. We have not had a holiday in a long, long time. I want you to be able to enjoy it. So please use your time wisely tomorrow. Okay? Get as much of it as you can get done. Bring your notebooks. Look up anything that you need to look up so that you can get it done. And then I am going to give you till Monday so that I will be back on Thursday just in case there's anything major that I need to go over that you don't understand. Okay? Everybody good with that? And then we're going to come back to this on Thursday. So we'll finish this up on Thursday and do some more exercises with it, make you feel really comfortable with it. The way second block ended up today, I had a couple that were great with it, and the rest of the class was in the middle. Okay with it, not great with it. So I think by Thursday you're going to feel really good with this. Okay, it's a lot of buttons to push. We're going to be doing it all in our calculator, but I think once you get the idea, you will be fine with it. So we'll finish this up on Thursday. I'll answer some questions on Thursday on your packets, and then you'll have a holiday on Friday. Okay, any questions? Okay. All right. Scatter plots. We're going to look at scatter plots today. A set of data graphed as ordered pairs in a coordinate plane, and we're going to be looking at real world situations. So my question to you is, when you graph real world situations, will it always make a perfect shape? No. Okay, and that's because there's a lot of variables to consider when you're doing real world situations. So you might have something that looks like this if you graphed. And so it's going to kind of be all over the place, but there will be sometimes a certain trend that goes with it. So we would draw a line of best fit. Where would a line of best fit go? In the middle. It's going to go through as many points as possible, and the points that it's not touching, it's going to try to keep the equal distance from the line. Does that make sense? It's not going to be shifted closer to one side than the other. So if I'm looking at this point and I'm going to look at this point over here, we're going to try to keep those equal distance from the line so that the line is truly in the middle and it gets as many points as it possibly can. That will be your line of best fit, okay? Now, we learned if the line is moving up as you go from left to right, that is generally called a increasing or a positive trend or a positive correlation. Okay, we know if the line is going down, then that would be a negative trend or a negative correlation. You might have something that looks like this today. So it might look something like that. What would that be? A parabola. Okay, as you go from the left to the right, it's decreasing and then it increases. So we're not going to necessarily look at linears. Okay, so we're not necessarily going to be looking at just strictly linear. We might be looking at some quadratic regressions. Okay, we might even look at something that would look something like so. So what would that be? That could be an exponential, okay, and that's very possible. Or what if this were, could it be like that? They might be quadratic. So it might be quadratic, or if I did it again, it might just be exponential. Okay, we don't know, but there is a deciding factor that's going to help us determine what is going to be the best one to use. Does that make sense? And that is called your correlation coefficient. Okay, before I go to the next slide, is everybody good at that? Scatter plots are not going to be exact. You're going to have to use a line of best fit that goes through as many points as possible, and the points that are not on the line should be equal distance from the line on either side. Okay, that is your line of best fit. And it might not just be a line. We're also going to look at quadratic regressions. We're going to look at exponential regressions, and we're also going to look at possibly even some logarithmic regressions. Okay. All right, let me let you go ahead and get this down. I will tell you this. We're not going to use that. That's a type. Okay, so the correlation coefficient is going to be used, we're going to be using the variable r. Okay, and r is going to be between -1 and 1. And the correlation coefficient is the measure that shows how well the data is modeled by the equation. So the closer it is to 1, if r is 1, if r is 1, or even if it's -1. If it's 1, that just is talking about a positive correlation. And if it's -1, it's just referring to it being a negative correlation. But if r is exactly 1, do you know what that means? If it's exactly 1, then that means it's a perfect line. That means the line goes through every single point. So the closer it is to 1 or -1, the better the line is. Okay? If it's 0, then that means the data has absolutely no correlation whatsoever. That would be like me comparing your shoe size to the hours of TV you watch. Tell me, what's the relationship between your shoe size and the hours of TV you watch? The people that have bigger feet watch more TV. Does that make sense? No, those two variables have nothing to do with each other. So if you like went around and collected data on that and plotted it, what kind of R value would it would have? It would have something close to 0. So when R is close to 0, it has absolutely no correlation. When it's close to 1 or -1, the closer it is to 1 or -1, the better the correlation, the better the line. Okay, so if we had an R value of 0.6, 0.6, would that be a good line or a bad line? It's not going to be a very good line at all. Okay, 0.6, even though that's closer, even though it's over half, I'm going to tell you right now, a 0.6 line is still not going to be a very good correlation. Okay. If we want a good correlation, we're looking at something like 0.997. If it's 0.997, that's pretty close to 1. So would that be a good line? That would be a great line. Does that make sense? So it's like a good correlation, positive or negative. It could be positive or positive. It's how well the line fits the points. Does that make sense? How well the line fits the points. So, and the whole positive and negative, if it's close to 1, then that just means it's a positive correlation. So that just means that the closer it is to 1, it'll be a better line. Even if it's closer to -1, it can still be a great line and be close to -1. But if it's close to 0, it's not a good line. Does that make sense? Okay. Generally, I want to say if you're talking, like people don't even consider good lines until they're at least like 0.75, 0.8. Something 0.8 and above would be like, anything below that is like not good at all. Okay. Any questions about the correlation coefficient? All right. Remember yesterday I told you the only thing difficult about this is what? There are a lot of buttons. So here's a step-by-step guide for buttons. So if you are not one to take every note down, I'm going to tell you right now, you want to write all of this down because it's going to give you a step-by-step guide of what buttons to push. Okay? I'm sorry, but if you want a step-by-step guide of what comes next and what you have to push, this will be it. Okay. Do you remember way back when I told you when you go into your SOL and I hand you a calculator, there are two things that needs to happen in your calculator. Who can name one? Turn on your imaginaries. Go to your mode and turn your A plus BI. Okay, that's one. The second thing is you've got to turn your diagnostics on. Okay, now what I'm going to do is I'm going to start first by not turning our diagnostics on because I want to show you what happens when they're not on. Okay, and then I'm going to show you what happens when they are on. Okay, but that needs to happen. You've got to turn your diagnostics on. And what do your diagnostics show you? They show you your R value. Does that make sense? It'll show you your R value when they are turned on. So you can see your correlation coefficient and you can see if it's a good line of fit or not a good line of fit. So let's go to example 1. So what we're going to do first is let's just look at it. I have given you a list of foods, and there you don't have to copy down the whole list, okay, because we're just going to do this in our calculator. But we're going to use the list because we got to get these numbers into our calculator. We're comparing the total fat to the calories. Is there a relationship between fat grams to calories? Hmm? Well, do you think things that are high in fat will be high in calories?
Yeah.
Do you think things that are low in fat will be low in calories? Do you think, and someone said, well, not really, because look at this. Like a hamburger has 9 grams of fat and 260 calories. But if you go down here to the grilled chicken light, it has less fat, but what? More calories. Huh. So we're going to figure out if there is a relationship between the fat to the calories. And we're going to predict what the calories are when there's 22 grams of fat. Okay, so that's what we're going to do is we're going to see if there's a relationship and see if there's an equation that goes with that relationship and then possibly make a prediction from that. So the first thing that we're going to do is we're going to put this into our calculator, and I'm going to exit. I can't exit. All right. And I think, all right, there we go. If you need to move up, you can move up so you can see. But what I'm going to do is I'm going to go to my stat. So we're going to press the stat button first right here in the center. And I'm going to press edit. So I'm going to press enter. And if you've got things in your list, to clear your list out, I'm going to arrow up to L2 and hit clear and then enter. And then I'm going to do the same for list 1, hit clear and enter. Does everybody see a L2 and a L1? Because if you're working in L3, sometimes people's settings are messed up. And if you don't have an L1, it's not going to work. Does everybody see L1 and L2? All right, so we're going to just put in our total fat into our list 1. So 9, 13, 21, 30, 31, 31, 34, 25, 20, and 5. You did. We we didn't look at different ones. We didn't look at our correlation coefficient in Algebra 1. We strictly stuck to linear and quadratic in Algebra 1. But But yes, we did do some of this in Algebra 1. Just, we're going to do a little bit more with it now. Whoops. And do make sure, here's what I'm going to tell you. We had some issues with this on second block. If you make one little typo into your calculator, what happens to your answer? It's going to throw it off, okay? So make sure you get things in and punched in correctly. And I'll wait for you once you get it in. And if you need to slide up, if you can't see it, you can slide up. So we've gotten our list in our calculator. And we want to look at the picture. I recommend you look at the picture because if it's a, if it definitely looks like a parabola, then it'll kind of give you an inclination of what we're looking at. So I'm going to hit graph. Okay. Now my graph, I don't see anything. Now you need to make sure your y equals is cleared out. Make sure you don't have any equations in your y equals. Because if you have equations in your y equals, that's what you're going to be seeing. Okay, so clear out your y equals. There should be nothing in your y equals. What's my issue? Why did I not see anything? Okay, so first of all, I've got to tell it to plot some points. So first things first is I need to go to my y equals and I need to turn my plots on. So you have to arrow up to where it's blinking and hit enter and turn your plots on. And then I'm going to hit graph again. I still don't see anything. So look at your window. Right now on a basic window, I go 10 this direction and I go -10 this direction. And then on my y's, I go 10 and -10. That's what my window is sitting at. Well, look at your endpoints. Look at my x's right here. What are my x's going from? 5 all the way to 34. So I need to fix my window. Okay, and look at my calories. Look at my y's. What are my y's going from? 260 all the way to 590. So do you understand? 260 is way up here. Well, this is only going to 10. Okay, that sounded very country, didn't it? Okay, to 10. So what we're going to do is we're going to fix our window. So we're going to look at our x min and our x max, okay? Our minimum is your smallest to your maximum. So I would just hit window right there beside of y equals. Okay? And so here's what I'm going to say is that I want you to leave a little room on either side. So we know we're going from 5 to 34, but give yourself a little room. So let's take our window from 0 all the way to 50. Like, I would give yourself plenty of room. And I'm also going to tell you this. Make sure your prediction is included in your window. Like, what are we going to be predicting when x is 22? Okay? We want our fat grams to be 22. So I need to make sure that 22 is in somewhere in between 0 and 50. Okay? Because if it's not, like, let's just say I wanted to predict when the fat grams were 55. Well, right now I'm only going from 0 to 50. So will the calculator find it if it's not in it? Does that make sense? So when the fat grams are 22, it's going to work. Okay, so how about our y mins? We're going from 260 all the way to 590, but give yourself a little room on either side. So let's do, plenty of room. Don't 200 all the way to 600. I'd even go past 590. That's pretty close. Like, again, I'm going to go on up to 700. 650 or 700. Like, give yourself some room so that you can include your prediction. Okay? And then I'm going to graph. And now I can see the points that I've plotted. Okay? Is there a correlation? Well, could we draw a line of best fit? Yeah, we definitely could draw a line of best fit. So there is a connection between our fat grams and our calories. Okay, there is a connection between there. So here's what we're going to do is we're going to go look at our we're going to look at our R values and make sure it's a good line. Remember I told you it's got to be close to 1. The R value needs to be close to 1 in order for it to be a good line. All right. So I'm going to go to stat and I'm going to calculate. Now let's just look through our list real quick so you can see the different equations because you're going to be pushing all different types. Choice 4 is our linear regression. AX plus B is the same thing as MX plus B. Okay, that's your linear. Okay, choice 4. I did stat and then I arrow over to calc. Choice 5 is our quadratic. So if I wanted to see the quadratic equation, that would give me that choice. Choice 6 is my cubic, so x cubed. Choice 7, what would quartic be? To the 4th power. There you go. If you choose choice 10, that's your exponential regression. And we're going to be looking at that. We possibly might be looking at the ln. The ln is the natural log. Okay, so if we look at a logarithmic, we'll be looking possibly at the ln. Okay, in Algebra 2, most of the time we stick to linear, quadratic, exponential. Okay, we might though, you might see one that looks, and you might see, someone said, would I ever see a cubic or a quartic? It's possible, but most of the time you're either going to see a linear or a quadratic or possibly an exponential. Those would be the top 3 most popular. Okay, so let's look at our linear. So I'm going to choose choice number 4. And you might have to hit enter a couple times. I got to go all the way down to calculate, and I've got to make it calculate. Now that gives me the equation. And what could I do with those numbers? I could plug into A and B. So I could have, the equation could be y equals 11.7x plus 193.9. Okay, so we're supposed to be seeing some R's. And this is why we hadn't turned on our diagnostics. Okay, so I told you I wanted to start by looking, I want to show you if you want to see some R values and I want to see how good it is, you should see some R's right now. And if you're not seeing R's, that's because your diagnostics aren't on. So let's go back to turn our diagnostics on. So we're going to go to our catalog, and you can arrow down to D if you want to, or you can, I'm at alpha right now, and I can use the green D, and it'll jump to my D's. And we're going to go down to where it says diagnostics on, and you've got to press enter, and then enter again. Okay, to where it says done. So once we have our diagnostics on, if I go back, stat, calc, and I go back and look at my linears and calculate, I should now see my R value. And my R value is 0.9746. Okay, is that a good line? Yes. And you could, you know, look, this one, I can tell you right now, this one's going to be linear because where I got this from, it's asking you to find the linear equation. We know, and that makes sense, the higher the fat, generally, not always, but generally the higher the amount of calories. So it will be a linear, and that is a pretty strong line to be a R value of 0.97. Okay, so what we're going to do is we're actually going to put the equation into y equals. Now, if you write, you could, and I would not recommend rounding. If you round it right now, what's that going to do with your prediction? What's that going to do with your prediction? It's going to affect it a little bit. So we don't want to round. So I'll give you 2 options and you choose. Option A, do you want to write all of the decimals and plug it in and type it into the calculator? If you would like to do that, you are more than you can do that. How many of you would like to cut, like you do on a computer, and paste into y equals? Anybody want to cut and paste? So you don't have to do any decimals. So watch this. All right, we're going to cut and paste. So let's go to y equals. This is step 6 if you're using your notes. And this is the one you got to have each little piece. So it says to go to y equals. Then what does it say to push? So you got to tell it where we're going to cut and paste to. So we're going to, from y equals, we're going to go to vars. Then what? Statistics, choice 5. Then what? So we're going to arrow over to equation. And then which equation do we want? We want choice number 1, the regular equation. And you know what we've done? We have just now snipped that equation, that all those decimals that we have, and it's now all in y equals. It'll get easier the more we do. I promise you. It'll get so easy. Okay? So from here, hold on, I'm almost done. We're going to graph, and we're going to draw our line of best fit. Okay? And you have to draw the line of best fit. You cannot, if you don't graph this, it won't be able to predict for you. Does that make sense? And if you don't put the equation into the y equals, it won't predict for you. So the last thing that we're going to do is we are now using that line. We are going to now predict when the fat grams are 22, what the calories are. So we are going to go to second calc, and we're going to calculate a value, and x wants to be what? 22, and we're going to hit enter. So tell me, when there's 22 grams of fat, what would the calories be? So if we rounded it, it'd be roughly around 452 calories. Okay? Now, I know that was a lot, but again, it'll get easier. I promise you it will. So what we're going to do before lunch is let's go ahead and look at example 2. Okay. So I just want you to go ahead and let's look at this, and then I'm going to let you put it in your calculator. If you would like to clear your list, you need to arrow up to L1. So you're going to go to Stat, Edit. You're going to arrow up to L1, and you're going to hit Clear and then Enter. And then you will arrow up to L2 and hit Clear and Enter. So let's look at what we're seeing here. The table below lists the Americans who are expected to be over 100 years old for the selected years. I want to know how many Americans will be over 100 years old in 2008. Okay? So first things first is go ahead, and I'll try to make it a little bit bigger so you can see. Let's put this. How's that? Is that good? So you can see. But you don't have to do the thousands. Just do it 50, 56, 65, and we'll just know that whatever you get for your prediction will be in thousands. Does that make sense? Yes. Okay. Hang on just a second. All right, so I'm going to stat, edit, and I'm going to hit clear and enter. And I'm going to put this in, so 1994, 1996, 1998, 2000, 2002, 2004. And then I'm going to put in 50, 56, 65, 75, 94, and 110. Okay, so when I go to graph, first of all, what line am I seeing?
The line you did last time.
Yeah, I'm still in example 1, so I need to clear that out. Okay, so I still don't see anything. I've got to fix my window to fit my data. So, look at my X's. We want to go from 1994 to 2004. And listen carefully, too. I want to make a prediction in 2008. So, I need to make sure that my window includes 2008. So, what do I want to do? 1950 all the way to 20/20 is what I heard. And is it okay if you're different? As long as, give yourself some space on either side. Okay? And my y's, I want my y's to go from what? I'm going to go from 0 up to 200. And I would definitely give yourself some room. Like, what if this is an exponential? So what if after 110, it does what? Shoot straight up. So you need to make sure to give yourself plenty of room on either side. So I'm going to graph, and we'll pick up there when we get back from lunch. Okay, so we graphed this once we fixed our windows. My question is, what do you think it looks like? It could be maybe a little bit of a half of a parabola. It also could be exponential, okay? But we don't know which one it is. So we're going to take a time to look at the R values to see. Sometimes it will tell you, go get the linear, or go get the exponential, or go get the quadratic. Sometimes it will be very obvious, and it will tell you in the question. So I always say, read carefully, okay? But if it doesn't tell you, sometimes it will say, which one's the best one? And so you're going to have to look at the R values of all the different possibilities. So let's go to Stat and to Calc, and let's go look at the linear first. Okay, so let's do choice 4 first. So we know the linear is about 0.98. Now, is that a good line? Yeah, that's not bad. Okay, that's not bad. So we know the linear, I can't get to anything because there we go. So we know the linear can't get this to write. All right, let's see if it'll write from here. We know, well, okay, so since I'm not going to be able to write on this, we know the linear is 0.98, but let's look at the other options and let's make a decision as to which one's the best one. So let's go to Stat Calc and let's go down to the quadratic. And let's go look at the quadratic. Now, does the quadratic give you the R value? It gives you the R squared value. So if I want the R value, what do I need to look at? I need to take the square root of that. And don't just take the square root of 0.9 or even 0.99. You need to use quite a few of those decimals to get it. So what is the square root? Help me out. What's the square root of 0.9972519? What's the square root of 0.9972519? Let's put it in our calculator and figure it out. What's the square root of 0.9972519? So what is it? Okay, so 0.9986, okay? So that's my question. For the linear, we got 0.98. For the quadratic, we get 0.998 something. Which one is better? So far, the quadratic's better. Let's take a look at the exponential and see which one, if that's any better. And you could look, if you wanted to, you could look at the natural log too. So if I took a minute and looked at the ln or the natural log, okay, the natural log is 0.98. So does that work? The natural log is 0.98. Is that any better? No, 0.998 is going to be closer to 1. So far the quadratic is the best. Let's look at the exponential just to make sure. So if we go down to choice 10 and click on the exponential, it's 0.994. Now which one's better, 0.998 or 0.994? 0.998 is closer to 1. So you have to look at all the R values and pick the one that's closest to 1. That's going to be your best fitting line. So we need to use the quad. Now my question is right now I have calculated the exponential. Do I want to cut and paste that guy into y equals? No. We want to cut and paste the quadratic. So we need to go to Stat Calc and go back to the one we choose and make sure you have calculated it. Okay? Now, if you wanted to, it gives you the quadratic equation, ax squared plus bx plus c. If you wanted to, you could, type in all those decimals and put the a where the a goes, put the b where the b goes, put the c where the c goes, but most of us do not want to do that. So what we're going to do is we're going to snip it. We're going to cut and paste all of this into y equals. So we're going to go to y equals, and what do we hit from here? Vars, statistics, over to equation, regular equation, and now that has cut and pasted all of that into y equals. Okay, are you with me? All right, then we're going to graph, and we're going to draw the line of the quadratic. And that is a pretty good line because it is going through a lot of the points, okay? And the last thing that we're going to do is we are going to make a prediction. I want to know, using the quad line, I want to know what's the prediction when it's 2008. So we are going to go second, calc, and we're going to calculate a value for 2008. Not 208, 2008. And so, how many thousand Americans would be over 100 years old? Yep, 157-ish. Okay? Any questions about?
When we write like the line, always
Say that again.
like say we write
Oh, you talking about like the output. You can say about 157,000 people. Like generally, if you're talking people, do you do like do you do fractions of people? Does that make sense? So, I mean, but it depends on what you're talking about. If you're talking about money, then you might round it to the nearest hundredth because you might do it to the nearest tenth. So it'll generally give you, you would just round it off most of the time because most of the time it's a real world situation. So most of the time in the real world we don't do fractions of people. We just round to the nearest person. Yep. 3. All right, so we're going to do one more, and I want you to try this one on your own. Okay? I want you to read it and see if you can get your window and make your prediction. Okay, if T is the number of years since 1950, that is going to make 0 1950. All right. I'm not going to be able to write on the board. This is 1950. So what does that make that year? And then that year? And then this year? Okay, so what would 2000 be? Well, how many years is 2000 from 1950? 50. So your prediction's going to be for the year 50. Does that make sense? And you can do it either or. The question is okay, so does that mean I need to type in 1950, 1955? I mean, if you wanted to, if you'd rather do it in years and that makes more sense for you to do it in years, that would be fine. But if you're going to use it as this table is 0, 5, 10, this would be 15, 20, 25, 30, 35, 40 years from 1950 is 1990. So you can just use 50 to be 2000 because that's what it is. Okay, so I have the data into my scatter plot, but I don't see anything. Well, I do see something. I still have the parabola from the last one in, so I need to clear that out. I still don't see anything, so what do I need to do? I need to fix my window. So my window, I'm going to go from year 0, and you can go into the negatives if you want, all the way to, I would do 70, 80, 90, 100, something like that. We need to make sure we know that the year 2000, our prediction is going to be year 50. If 50 years from 1950 would be 2000. Okay? So I need to make sure I go above that. So I'm going to go 80. Okay? And I need to know, what about my y's? I want to go from 0 all the way to, this is up to 10,000. So I need to make sure I go to, I don't know, I'm gonna go on up to 20,000. Well, I mean, this is 10,000. Okay, this is 10,000 on my y's. Right there, 9,959 is pretty darn close to 10,000. So I need to make sure I give it a little bit of room. And so I'm going to graph it, and there it is. Now, I could, if I did not tell you which one to go get, then how would you know which one to go get? You would have, by looking at the R value, guys, please, I need you to listen. It's too much talking and people going, I'm lost, and you're not listening. If I don't tell you what to go get, then you need to look at your R values. You would have to look at your linear, check the R value. Look at your quad, check the R value. Look at your exponential, check the R value, and choose the best one. But in this case, it's telling us to check the exponential. So I'm going to go get my exponential one because it's telling me, go get the exponential. And so part A says my R value is 0.979. And it says, is the exponential model a good fit? Is 0.979 a good fit? Is it an exact fit? No, but it's a fairly decent fit, okay? And when you graph it, you can see, which from here, what I need to do is I need to graph it. I've got to vars, statistics, equation. We're going to go snip that equation, and then we're going to graph it. And you can see that it doesn't go exactly through every point, but it's a good fit. Okay, it's a good fit. And so then we are going to make our predictions. So second, calc, value. What do we want x to be? Do I want to put in 2000? No, I want to put it in like my table. And in my table, according to my table, 50 would be the year 2000. If you put in 2000, what's going to happen? Error. How many put in 2000? Does that make sense? Now, how could you put in 2000? It would be okay to put in 2000 if your years were like what? 1950, 1955, if you're going to use that and use your window, but remember my window only went from what, 0 to 80? So I didn't include 2000 in 0 to 80. Remember how I said it had to include your prediction? So around 35,653 cranes would be in the year 2000. Sky. invalid dimensions. Sometimes that means that like you got too many in this column and not enough in this column. You have to have the exact same amount in your X's that you in your list 1 that you do in your list 2. So if you forgot one, it's going to be your others. I'll have to come look at it and see if there's something wrong with it, if you hit something wrong. I will show you this. Have I showed you how to clear your memory in case your calculator gets all messed up? So do I need to refresh your memory on how to clear your memory?
Yeah.
So I will tell you right now, if you want to clear your memory, second mem is your plus sign. And you can reset. I'm going to go down to choice number 7. And you can go over to all. And then I can reset choice 2 and clear your memory. Now, if you clear your memory, if you're doing something at home or you're doing something, if you clear your memory, what will you have to do to go back and do another problem like this? You got to turn your diagnostics back on. You have to turn your plots back on and do all of that. Now, I will tell you this. Once your plots are on, what if I ask you now just to go graph like a basic problem? What will you have to do? Turn your plots back off. Does that make sense? You're going to have to like go back and forth from turning your plots on and turning your plots off. Now, I will tell you, once your diagnostics are on, they'll be on forever, okay, until you clear your memory or reset your calculator or something like that. But so once your diagnostics are on, they're on for good. Okay. Any other questions? It doesn't affect anything in a bad way. It just turns your correlation coefficients on. Okay.